Hi, welcome back to Dynamics ECS429. You're here with me, Dr. Yasmin Saul Hamid, and today I'm going to explain to you an example problem that is available in your BA textbook, example problem 12.14. Now, the two blocks shown are originally at rest, neglecting the masses of the pulleys and the effects of friction of the pulleys, and assuming the coefficient of friction between block A and the horizontal surface are mu s equals to 0.25 and mu k equals to 0.2. Determine A, the acceleration of each block, and B, the tension in the cable. Okay, so what we need to do is we need to determine the tension of the cable, and we need to calculate the acceleration separately for each block. But what we first need to do is we need to determine the direction of the block. Now, the direction of the block. Now, if block A, okay, let's say we have block A here. So the direction of the block. So block A can either move to the left hand side or it can move to the right hand side. Now, if let's assume first block A moves to the left hand side, what will happen to block B? Now, if block A moves to the left hand side, block B will be raised up. And vice versa. So now what we need to do now is determine the direction. Now, how do we determine the direction of the block? Okay, now this is a good way into determining the direction for each of the block. Okay, so now follow my steps. Okay, first let's start with block B here. Okay, so block B has a weight of 25 kilograms. It means the weight will be equals to m mass multiplied by g. So 25 multiplied by 9.81 will equal to 245.25 newtons. So this weight will be transferred to each of the cables, and each of the cables behave in tension. So what does each cable carry? So each cable will carry a third of the weight of block B. So it means the weight of these cables will be 245.25 newtons divided by 3, and that will equals to 81.7 newtons. Okay, now this is the answer. This is not the answer for the tension of the block yet. What we want to determine is we want to determine the direction first. So in order to do this, we have to consider two cases involved. Number one is the case where the friction of the block A is moving to the left hand side, and the friction of block A is moving to the right hand side. Okay, now let's calculate the friction. Okay, hold on. Let's put in the weight for block A first. Oops. Okay. So block A, oops, difficult to draw straight. Okay, so block A will be equals to 30 multiplied by 9.81, and that will equals to 294.30 newtons, and the weight will be equal to the normal force of the block. So we also have a normal force of the block, which is, we consider the symbol as N. So the friction of the surface A will equal to mu k multiplied by N. So for this case, mu k, we will use the coefficient of friction due to kinetics, which is 0.2, multiplied by the normal. The normal will be the same as the weight, so it will equals to 58.86 newtons. Okay, so now okay, so now okay, where am I? Okay, now as I mentioned, we have two cases. Now, case 1 is when our friction is moving to the left hand side, okay? And then case 2 is when our friction is moving to the right hand side. Now, when our friction is moving to the left hand side, what we need to do is we need to consider all the forces that is involved in the left hand side. So if you look at the left hand side, what are the forces involved? We do not have any other forces besides the friction that we have assumed moving to the left. So it will equals to 58.86 newtons. Now case 2, okay, this one, what we're referring to block A. Okay, now for case 2, when the friction is moving to the right hand side, have a look at the diagram of block A. What are the forces involved? Okay, of course we will have the friction, the direction of the friction, and we will also have the tension value, and the tension is 81.7. So obviously what you can see here, the right hand side is much greater than the left hand side. What does that mean? What it means is our object A is going, our object or block, our block A is going to move to the right hand side. So now we know which side is moving. So our block A is going to move to the right hand side. So our acceleration is going to go that way. And how about block B? So when block A moves to the right hand side, our block B will obviously be moving downwards. Yeah. So now we have established the relation. Good. Okay, now, so the relation between the two blocks can be written in terms of the lengths. So now only we're going to determine the tension of the cables and the acceleration. Now, let's establish the lengths of the cable first. So let's say this is XA. Oops. And this is, okay. And this is X, no, let's choose YB. Okay, now let's establish the correct equation for this one. Okay, now, so we have XA plus 3YB will equals to the total length. Okay, now, when the length increases, the velocity is positive. And when the length decreases, the velocity will be negative. Now, since we have established that our block A is going to be moving to the right-hand side, okay, what does that mean? What will happen to the length of cable XA? So when our block A moves to the right-hand side, the cable of block the cable of XA will decrease. It means reduce. So when it reduce, it means our velocity will be negative. Yes, that's right. So now, how about block B? So what happens to the cable of YB? So when block A moves to the right, obviously the cables of attached to block B will increase. So that means our velocity for block B will be positive. And when you differentiate a constant, it will become 0. So you can do this similar with the acceleration value. There we go. Yippee. Okay, now our main task is to determine the acceleration and the tensions. Okay, now we need to draw the free body diagram and kinetic diagram for each block. Okay, so here we have block A. Okay, so we have a weight here, 294.30 newtons. We also have a tension of the cables. Okay. All right, and we also have the friction. Since we know it is moving to the right, So it means our friction will be the opposite direction, which is 58.86 newtons. Yes. Now, this is what you call the free body diagram for block A. Now you need to draw the kinetic diagram. Okay. So this will be our kinetic diagram. Okay, done. Now, let's write the equation. So since the equation will be in the fx direction, fx equals to max. Now, since our block A is moving to the right-hand side, the dominant will be the T, the tension. So our tension will be positive. Okay, our tension will be positive minus 58.86 equals to the mass, which is 30 A, acceleration at A. Okay, so what we need to do, we need to make the in terms of acceleration, because we're going to put this equation in this equation, this relation, which is negative A plus acceleration B equals to 0. Okay, so then we will get T minus 58.86 divided by 30. Okay, goody. Okay, so here we have this equation number 2. Okay, next we need to establish the equation for block B. Okay, so block B is moving downwards with, we know block B is acceleration is moving downwards. The force is 25 newtons. And we also have 3 cables here in tension. And this will be our free body diagram. Next, you need to draw the kinetic diagram. So, MAB. Okay. All right. Now, let's write down the equation. So this equation, we will consider Fy direction, MAB. So in Fy direction, since our acceleration is moving downwards, the dominant value is the force. So our tensions of the cable will be negative. Okay, 3T equals to 25 AB. So AB will equal to 245.25 minus 3T divided by 25. So this will be our third equation. So what you need to do now is put in equation 2 and 3 into equation 1. So let's put equation 2 and 3 into equation 1. Okay, now, so let's write down back our equation 1. So equation 1 is negative acceleration at A plus A. Oh, I've missed something out here. This is, don't forget to put the 3 value here. Okay, I forgot to put the 3 value here. Please bear in mind. Okay, sorry about that. Is it okay? I hope we're okay. Okay, forgot about that. Okay, 3 acceleration at B equals to 0. So what is our acceleration at A? Our acceleration at A is T minus 58.86 divided by 30 plus 3. What is our acceleration at B? Our acceleration at B is 245.25 minus 3T divided by 25 equals to 0. Okay, now if you simplify this, you will get negative 0.3933 T plus 31.392 equals to 0. So then you can get your answer for T. That will be 79 79.81 newtons. Okay, so the answer is 79.81 newtons. Yay! So we have got this answer. So now we need to find the acceleration for each block. So that will be easy. All you need to do is just replace t with 79.81 minus 58.86 divided by 30. You will get the answer to be 0.698 meters per second squared. Am I correct? Okay, same goes for acceleration B. So acceleration B will be 245.25 minus 3. T is 79.81 divided by 25. You will get the answer for the acceleration at B to be 0.233 meters per second squared. Yay! We've completed this question. Okay, I hope you're happy. Okay, all right, so let's just recap. So for this question, how you solve it first? Number one, you have to determine the direction of the motion for the block, and from here we have achieved that the direction for the motion of block A, it is going to the right hand side, and block B is going down. So when you have established that equation, you will manage to come up with the equation of positions where it is xa plus 3yb equals to tl, and when you differentiate velocity, when you differentiate position, you will get velocity. And why there is a negative for velocity A is because when block A moves to the right hand side, the length of the cable XA will reduce. So when the cable length decreases or reduce, our velocity will be negative, and vice versa. Okay, so after that you can establish you draw your free body diagram and kinetic diagram for each block, and use the Newton's second law equation F equals to ma to get the equation here. So here we have established our equation for acceleration for block A and block B, and all you need to do is put it into the equation, and then you can find the tension of the cables, and then the tension of the cable is put into the equation of acceleration. Then you can find the acceleration for each blocks. Okay, that's how you solve it. I hope you understand how to do this and try more tutorials. More tutorials. Okay, thank you.